Hello everyone. Again welcome to Numerical series of utilization. And today our numerical problem is the magnetization character of DC series motor when running at 500 RPM is given below. This is the magnetization characteristics, current and EMF. When current is 20, EMF or voltage is 215, 30, 210, 40, 381, 50, 437, 60, 485, and 70, 519, 80, 550. The resistance of armature and field are 0.5 when connected to when connected for dynamic braking against an overhauling load of 500 Newton. If the motor is to be maintained at 600 RPM, what resistance must be connected across the motor terminal? We have to find the resistance that should be connected across the motor terminal. We know KEF equal to E upon WM. WM equal to 2 into 500 upon 60. This 500 RPM, this 500 in RPM. So if you divide this by 60, it can convert in RPS. And T equal to KE phi IA. From this relation, we can the data of the magnetization curve is. This is IA. Same, we can write this value same as it is. And KEF, and here KEF equal to E upon WM. So E1 is 215. Divide 250 upon this value, so we can get 4.11. Again 310 divided by 310 divided by this value, then we can get 5.92. Again similarly 7.28, 8.35, 9.27, 9.92, and 10.51. And torque equal to Ke phi Ia. This is Ke phi and this is Ia. So multiply this and this, 20 and 4.1, they 30 and 5.92, say 40, and then you can get all this value of torques. And after getting the value of torques, plot this value in the graph. You can put this value in graph. KEF and T versus IA. This is KEF, this is T, and this is I. And here put all the data. First of all, put this I versus, this is KEF, and this is I versus T. This graph is I versus T, and this graph is I versus KEF. So from the graph, for a torque of 500 Newton, I equal to 56 ampere and KEF equal to 8.9. This is the value of I equal to 56. This is 56. In this point, all the curves are cut. These curves and these curves cut. So in IA curve, the value is 56. If you draw in the graph paper, then you can get the exactly value. And KEF equal to 8.9. This is the value of KEF. And here you can see this is 8.9 something. Then for a speed of 600 Newton, E equal to KEF omega. So 8.9 into 600 upon 60 into 2.5. This is for 600. In the question given, you can say this is 600. For this 600, we can get E equal to 559.2. So RA plus RB equal to E upon IA. Then the value of E is 559.2 upon 56, that is 9.985. Then RA plus RB. In the question given, the total resistance of armature and field is 0.5. So RA plus RB equal to 0.5. Then RB equal to this value minus 0.5. Then we can get RB equal to 9.485 ohm.